Hi, in this video, we'll start a new section in our course. This is the section on advanced inequalities. So the first one that we are going to look at is mean value inequalities. So let me just tell you what the inequalities are. So let A1, A2 till AN be n positive real numbers, and let's call Hn. This is the harmonic mean. This will be n by 1 by a1 plus 1 by a2 till 1 by an. Then we have gn would be a1, a2 product an to the power 1 by n. And we have an is the arithmetic mean. Gn was the geometric mean, and arithmetic mean is a1 plus a2 till an by n. And finally, we have the square mean. So what is this mean? Qn is the mean of the squares. So a1 square plus a2 square plus an square by n, and we'll do a square root of that. This is called the square mean. So once we have defined these four means, harmonic mean, geometric mean, arithmetic mean, and square mean, the inequality states that we have Hn is always less than equal to Gn, is less than equal to An, and is less than equal to Qn for all positive real numbers A1 to An, where equality happens when A1 is equal to A2 is equal to An. So the inequalities are Hn is less than equal to Gn, is less than equal to An, and less than equal to Qn. And equality happens in all cases when the numbers whose means we are taking are themselves all equal. Right. The proof for these inequalities can be done for the two variable case very simply by algebra. And for n variables, you can use induction to try to prove all of them. So the proof, I will leave it to you. Induction methods can be used to do that. What we will do is apply these inequalities in problems and learn how to use them in our Olympiad questions. So let's start with the first one. Let ABC belong to real numbers. Excuse me. And the product of ABC is less than equal to 1. We have to prove that 1 by A plus 1 by B plus 1 by C is greater than equal to 1 plus 6 by A plus B plus C. Correct. So this is what we have to prove. The first step that we'll do is we'll transform this inequality a little bit by multiplying both sides of it by A plus B plus C. So we can say A plus B plus C multiplied by 1 by A plus 1 by B plus 1 by C is greater than equal to A plus B plus C plus 6. So that is what we have to prove now, right? Now we know that 1 by A plus 1 by B plus 1 by C will be greater than equal to 3 times the cube root of 1 by ABC, right? The reason we know this is because AM is greater than equal to GM. We are taking the AM and GM of these three quantities. These are positive, so we can apply them. And therefore now, since ABC is less than equal to 1, we can say that 1 by A plus 1 by B plus 1 by C is greater than equal to 3. Why? Because ABC less than 1 means this number will become greater than 1, right? So we have this inequality directly, right? On the other hand, the second step here is we can say 2 by 3 of no, before that, what we will do, we have gotten this. So what I want to find out is what is 1 by 3 of a plus b plus c multiplied by 1 by a plus 1 by b plus 1 by c, right? Now, this thing will be greater than equal to a plus b plus c. Why is that? Because we know that 1 by a plus 1 by b plus 1 by c is greater than equal to 3. So 1/3 of 1 by a plus 1 by b plus 1 by c is greater than equal to 1. Therefore, if I multiply 1/3 of 1 by a plus 1 by b plus 1 by c with a plus b plus c on both sides, from here it follows that this is true, right? Great. So we have established this result. Now, what is 2 by 3 of a plus b plus c multiplied by 1 by a plus 1 by b plus 1 by c? Let's try to establish an inequality on that. Now we can apply a and gm to both of these terms. We can say that this is greater than equal to 3 times cube root of abc, and this is greater than equal to 3 times cube root of 1 by abc, right? So this whole thing will be greater than equal to 2 by 3 into 3 cube root of abc into 3 cube root of 1 by abc, where this cancels this and 3 cancels here. So this is greater than equal to 6, right? So we have established that 2/3 of this is greater than 6 and 1/3 of this is greater than a plus b plus c. So obviously if you add both the left sides, right, you will get a plus b plus c multiplied by 1 by a, 1 by b, 1 by c is greater than equal to a plus b plus c plus 6, right? So basically you are using the original inequality and you're using AMGM twice. You're using AMGM here and you're using AMGM here to establish this. And once you have these two, we can add it up and see that the original inequality is true, right? Let's move on to the next problem. So here we have question number 2. We have assume that four reals A, B, C, D satisfy ABCD is greater than A square plus B square plus C square plus D square. We have to prove that ABCD is greater than A plus B plus C plus D plus 8. Okay. Now, what we can say here is that we will first of all do AMGM on A square plus B square plus C square plus D square. Let's do AMGM on this. So it is greater than equal to 4 times square root of fourth root of A square, B square, C square, D square, which is equal to 4 times root of ABCD. Right. So what we get from this is that A square plus B square plus C square plus D square is greater than equal to 4 times root of ABCD. So correct. And this itself is greater than, basically we can say 4 times root of A square plus B square plus C square plus D square, right? Because we are using this condition. ABCD is greater than this, so we have replaced this. So from here, overall, what we can conclude is a square plus b square plus c square plus d square is greater than 4 times root of this, right? So we know from here that root over a square plus b square plus c square plus d square is greater than 4. This is a conclusion that we get from using the data and AMGM on a square, b square, c square, d square. Now, in order to prove this statement, let's attempt a proof by contradiction. So suppose we'll assume the opposite. So suppose ABCD is less than equal to this. ABCD is less than equal to this. Then this implies that ABCD was itself greater than this. So this implies that a square plus b square plus c square plus d square is less than a plus b plus c plus d plus 8, right? So if you simplify this a little like this, construct quadratics, you have b square minus b plus c square minus c plus d square minus d is less than 8. And we add 1 to each term here, add 1 to all the sides. So what we will have is not add 1 actually, we should add 1 by 4 to complete the square, right? We should say a square minus a plus 1 by 4 plus b square minus b plus 1 by 4 plus c square minus c plus 1 by 4 plus d square minus d plus 1 by 4 is less than 8 plus 4 times 1 by 4, so 8 plus 1, right? So what we have here is a minus half whole square plus b minus half whole square plus c minus half whole square plus d minus half whole square is less than 9. This is coming once we have assumed the assumption that we are assuming the opposite. ABCD is less than this. From here we are getting this, right? So let's apply AMGM on these terms, these 4 terms. So let's do it on the next screen. We know that a minus half plus b minus half plus c minus half plus d minus half by 4 is, this is the AM, and we are writing the AM is less than the QM, right? Which is the power mean of these terms. So what is the power mean? Power mean is the sum of the squares, mean of that, and root of that. So here in this step, what I am writing is AN is less than equal to QN for these quantities, right? So from here, what we can get is this is less than equal to this quantity is less than 9. So we have root over 9 by 4, which is equal to 3 by 2, right? So we are getting a plus b plus c plus d. This, the top part is a plus b plus c plus d minus 2 by 4 is less than equal to 3 by 2. So this becomes 2 and this becomes a plus b plus c plus d is less than equal to 6 plus 2, 8, right? So we are getting a plus b plus c plus d is less than 8. Actually, the less, it's not less than equal to 8 because at this step, we had a strict inequality. We knew that this was less than 9. So I should remove this inequality sign here. So we are getting a plus b plus c plus d is less than 8. But therefore, we can say that fourth root of ABCD is less than a plus b plus c plus d by 4. This is implying that GM is less than AM inequality. And we know this is less than 8 by 4 equal to 2. And we know that 2 is less than this, right? Why are we getting 2 is less than this? Because we can prove that actually 2 is greater than this, because using the information in the previous in the beginning, we can say that, let me just show you. Uh, ABCD, ABCD was greater than, the question itself said ABCD was greater than A square plus B square plus C square plus D square, which is greater than equal to 4 times fourth root of ABCD square, which is equal to 4 times root over ABCD. So from here we can say that root over ABCD is greater than 4, right? Root over ABCD is greater than 4. So ABCD to the power 1 by 4 is greater than 2. So we know this from the beginning, and we can also say from what we have established so far, we got from the contradiction assumption, we got A plus B plus C plus D is less than 8. And now we can establish this A plus B plus C plus D by 4 is less than 8 by 4 equal to 2. And this is greater than equal to fourth root of ABCD. And we know that that is greater than 2, right? So we are getting something is greater than 2, but also less than 2, which is a contradiction. We cannot have this quantity greater than 2 and also less than 2, right? So since it is a contradiction, that means our assumption was wrong. The assumption was ABCD was less than equal to, we had assumed that ABCD was less than equal to A plus B plus C plus D plus 8. So this assumption is wrong. Therefore, ABCD must be greater than A plus B plus C plus D plus 8. So we are using multiple things here. We are using power mean inequality also. Like we used AN is less than QN at one stage. We have used AM is greater than GM multiple places. And we have also used the technique of proof by contradiction, right? Let's go over to the next problem. Question number 3 says, suppose x1, x2, xn plus 1 are positive reals. We have to prove that 1 by x1 plus x1 by x2 plus x1 x2 by x3 plus x1 x2 x3 by x4 and so on till the last term is x1 x2 xn by xn plus 1 is greater than equal to 4 times 1 minus x1 x2 till x of n plus 1. We have to prove this, right? So what we will do is we'll try to get this pattern in an indirect way. So first we'll say let A and B be greater than 0. So by A and GM, we can say that 4AB plus A by B will be greater than equal to twice of root over 4AB into A by B, right? Which is basically equal to 4A. So from here we get A by B is greater than equal to 4 times A minus AB, right? 4A minus 4AB, right? Now, if you take x1, x2, here we will assume that I want to prove this 1 by x1 plus x1 by x2 and so on is greater than 4 times 1 minus this, right? So what we will say is we have this inequality that we want to use. So let's use it repeatedly. Let's say 1 by x1 will be greater than equal to 4 times Here A is 1 and B is x1. So it will be 4 times 1 minus x1, right? Similarly, x1 by x2 will be greater than 4 times A is x1 and B is x2. So x1 minus AB. So it is x1, x2, right? So if you write down all the terms like this, 1 by x1 plus x1 by x2 plus x1, x2 by x3 and so on till x1, x2, xn by x of n plus 1. Each term here is greater than 4, 1 minus x1 plus 4, x1 minus x1, x2 plus 4, x1, x2 minus x1, x2, x3 and so on till the last term will be 4 times x1, x2, xn minus x1, x2, xn plus 1. So there is a greater than equal to sign. This is greater than this is greater than this, right? So basically the sum of it will be greater than equal to the sum of this series, which if you realize is a telescoping series. So it becomes 4 times 1 minus x1, x2 till x of n plus 1. So what are we using here? We are basically saying that for any real numbers a and b greater than 0, 4ab plus a by b is greater than equal to 4a. So therefore a by b is greater than equal to 4a minus ab. And that we are using repeatedly on each of our terms, right? And that is what helps us prove this because it becomes a telescoping sum. Let's go to the next question. In this one, we have assume that A, B, C are positive reals and A plus B plus C is equal to 1. We have to prove that A by A plus B square plus B by B plus C square plus C by C plus A square is less than equal to 1 by 4, 1 by A plus 1 by B plus 1 by C. So here we have to try and simplify these terms somehow. So we can say A by A plus B square. We can see that the degree of the denominator has two terms of different degrees. One is a degree 1 term, one is a degree 2 term. Because of this condition, we can try to change that and make everything symmetrical. How? We can write this like this: A by A, and instead of A, we can write A into A plus B plus C plus B square, right? Because A plus B plus C is equal to 1. So this becomes basically A by A square plus B square plus AB plus AC, right? Now, we know by A and GM that A square plus B square is greater than equal to 2AB. We know this, A square plus B square is greater than equal to 2AB by AMGM inequality. So therefore, this will be less than equal to A by 2AB plus AB plus AC. So that becomes basically equal to, we can cancel the A throughout, 1 by 3B plus C, right? So what we are getting is A by A plus B square is less than equal to 1 by 3B plus C. So what we can see here is what is um, we can try and get an alternative fact here. We can say that this is 1 by B plus B plus B plus C, right? So 4 terms of B. So so can we prove something like this? 4 by C by B plus 1 by C, which is equal to 4 by 1 by B plus 1 by B plus 1 by B plus 1 by C. This is the HM of these four terms, should be less than equal to the AM of these four terms, right? Should be less than equal to the AM of these four terms will be C by B plus 1 by C by 4. C by B plus 1 by C by 4, right? So from here we can say that 1 by 3B plus C, we have A by A plus B square is less than equal to 1 by 3B plus C. Can we say from there that uh, we know 16 from here, first and third, we know 16 is less than equal to 3 by B plus 1 by C whole square. But that is not similar to 3B plus C. So, we have 4 by B plus B plus B plus C and 1 by 4 here. This is the HM of these terms. So that should be less than equal to the AM. Oh yes. We have this inequality. Basically, we have 4 by 3B plus C and 1 by 4 of that is less than equal to 3B plus C by 4 and multiplied by 1 by 4, right? So basically, I will do it on the next screen. We have established so far A by A plus B square is less than 1 by 3B plus C. Let's apply AM, GM, HM on this. So HM is less than equal to AM. So we know that 4 by 3B plus C will be less than equal to 3B plus C by 4. This is the HM of B, 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 and C. This is the AM of B, 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 and C, right? So therefore, 1 by 3B plus C is less than equal to 1 by 16, 3B plus C. Right? So we can say this 1 by 16, 3B plus C. Right. So we will get similar inequalities here. 3B by B plus into 3C plus A and C by C plus A squared is equal to 1 by 16, 3A plus B. So when you add up all of this, we are getting less than equal to 1 by 16 3a plus 3b plus 3c plus all of this. So actually it will become 4 times a plus b plus c, right? So less than equal to 1 by 4 we are getting. Now we are not exactly there yet because we wanted to prove that a by a plus b square plus b by b plus c square plus c by c plus a square is less than equal to 1 by 4 times 1 by a plus 1 by b plus 1 by c. Want to prove this, but we have already gotten that it's less than equal to 1 by 4. So if this is greater than 1, then we will be done, right? Okay. So we know that a plus b plus c is equal to 1. 1 by a plus 1 by b plus 1 by c. Perhaps it will be easier if we just do ANGM on these terms. 4 by 3 by b plus 1 by c. This is the HM is equal to 4 by 1 by b plus 1 by b plus 1 by b plus 1 by c will be less than equal to the HM will be less than equal to the AN 1 by b plus 1 by b plus 1 by c plus 1 by c by 4. So from here we will get that this will become hmm, there is some slight issue with this. Uh, right now I'm not getting the complete inequality yet. So we will move on. Uh, we'll come back to this problem probably towards the end. For now, I want to show you some more questions. That's why we'll just move on from this one for now. Let's look at another problem. This is question number 5. We have suppose A, B, C are positive real numbers satisfying product of A, B, C is equal to 8. We have to prove that a square by root over 1 plus b cube multiplied by 1 plus c cube plus b square by root over 1 plus c cube multiplied by 1 plus a cube plus c square by root over 1 plus a cube multiplied by 1 plus c cube is greater than equal to 4 by 3. Okay. So in this problem, we have ABC equal to 8. So one good way to make the problem a little simpler is if you take A as 2x, B as 2y, and C as 2z. In that case, ABC is 8xyz is equal to 8. So xyz is equal to 1. So we can convert the problem into, instead of ABC variables, we can write it in terms of xyz. We can say that this will become 4x squared by 1 plus 8x 8y cube 1 plus 8z cube plus 4y square by 1 plus 8z cube and 1 plus 8x cube plus 4z square by 1 plus 8x cube and 1 plus 8y cube is greater than equal to 4 by 3. So 4 can get cancelled. Basically, we have to show that x square by root over these roots, the roots have not changed, plus y square by these roots and z square by these roots is greater than equal to 4 divides to 1 by 3. This is what we have to show. Right. Now let's try to work on it in the next screen. We know that 1 plus y square is greater than equal to 2y. This follows directly from A and GM. So if you multiply by y square throughout, you get y square plus y power 4 is greater than equal to 2y cubed. So therefore, this implies that 4 times y power 4 plus 4y square plus 1 will be greater than 8y cube plus 1. We have multiplied by 4 and added 1. That's what I have done here. So that means 1 plus 8y cube is less than equal to 1 plus 2y square whole square. Right? So root over 1 plus 8y cube is less than equal to 1 plus 2y square. Right? So therefore, 1 by root over 1 plus 8y cube will be greater than equal to 1 by 1 plus 2y square. Right? So what we have to show was x square by root over 1 plus 8y cube 1 plus 8z cube plus y square by similar terms and z square by similar terms is greater than 1 by 3. We had to prove this inequality, right? So think of each of these terms. We know that 1 by 8y cube is greater than equal to this. So if we can show that x square by 1 plus 2y square, and similarly for 1 plus 8z cube, we can replace 1 plus 2z square, right? If we can show that the inequality here, every root over 1 plus 8 y cube or z cube, we replace with the corresponding terms. So this is z square and 1 plus 2x square plus z square by 1 plus 2x square and 1 plus 2y square. If we can show that this is greater than equal to 1 by 3, then it will automatically follow that this will be greater than 1 by 3. Because we know that this is true. 1 by root over 1 plus 8y cube is greater than 1 by 1 plus 2y square. So we have replaced it with something lesser. If we can prove the lesser inequality, then obviously the greater one will be true, right? So this is what we'll try to prove now, right? So how do you do this? We will simplify it a little bit by multiplying throughout by 1 plus 2x square, 1 plus 2y square, and 1 plus 2z square. So this will start looking like this. When you multiply throughout by 1 plus 2x square, y square, z square product, you will end up getting an inequality like this that we need to prove. 1 plus 2y square, 1 plus 2z square. Now this inequality, after a little bit of algebra, you can simplify this, is equivalent to the inequality x square plus y square plus z square plus 6 times x power 4 plus y power 4 plus z power 4, and that should be greater than equal to 9 plus 4 times x square y square plus y square z square plus z square x square. This is what we need to show now. And since we know that x power 4 plus y power 4 plus z power 4 is greater than equal to x square y square plus y square z square plus z square x square. How do we know this? Because this is always true. X square plus y square plus z square is greater than equal to xy plus yz plus zx. because we can rewrite it as half into x minus half whole square plus half into x minus y whole square plus y minus z whole square plus z minus x whole square is greater than 0, which is always true. This can be rewritten like this, therefore this is also true, right? So it is, since we know this term is greater than 6 times of this term, so this inequality is equivalent to x square plus y square plus z square plus 2 of these will be left. X4 plus y4 plus z4 is greater than equal to 9. 6 of, actually 4 of these we have said, we can take 4 of these and we can say that these left hand side is greater than this. So only 2 of them are left and we have to prove that x square plus y square plus z square plus 2 of them is greater than equal to 9, right? So this is what we need to show, but we know that x square plus y square plus z square is greater than equal to 3 times cube root of x square y square z square. And in the problem, we know that x, y, z is 1, so this is equal to 3. And similarly, x power 4 plus y power 4 plus z power 4 is greater than equal to 3 times cube root of x power 4, y power 4, z power 4, which is also 3. So we have here 3 plus 2 into 3. This is greater than equal to 3 plus 2 into 3, which is equal to 9. So basically we can show that this is greater than 9, which means this inequality is true. And this inequality is true means this is true and our original inequality was equivalent to this. So hence we have proved the original inequality. It requires some algebra at many of the steps, but eventually we are able to get there, right? Okay, now let's look at the next problem. We have question number 6. Assume that positive integers a1, a2 till an satisfy summation of I goes from 1 to n, I is equal to 6n. Summation I goes from 1 to n, I by ai is equal to 2 plus 1 by n. Find the value of n. Find the value of n. Okay. Now, what we will say here is we will say that 6n by n into n plus 1 by 2 is equal to a1 plus 2a2 plus 3a3 plus nan by n into n plus 1 by 2, right? Now, this is basically the am of all the numbers IAI, right? So that will be greater than equal to the HM, right? So what is the HM? That will be n into n plus 1 by 2 and divided by 1 by A1 plus 2 by A2 plus n by an. Why? Because the numbers are, how many numbers are there? There are n into n plus 1 by 2 numbers. Because we can write each of them like this, a1 plus a2 plus a2 plus a3 plus a3 plus a3, and similarly an plus an n times, right? So when you do the HM for them, the number of numbers is this, but each of the terms you have to take reciprocals and add. So you do 1 by a1 plus 1 by a2 plus 1 by a2, so it becomes 2 by a2, and similarly it will become n by an, right? So this is basically the AM HM inequality here. So now we will say that we can cross multiply here and we can say that A1 plus 2A2 plus NAN multiplied by 1 by A1 plus 2 by A2 plus N by AN is greater than equal to half of N into N plus 1 whole square, right? We are getting this result. Uh, Correct. Right. And we know that actually we didn't need to do this step also. We can just write the earlier statement A1 plus 2A2 plus NAN by N into N plus 1 by 2 is greater than equal to N into N plus 1 by 2 divided by 1 by A1 plus 2 by A2 till N by AN. This is the step. And in the problem itself, they have said that sum of the IAI is equal to 6n. So we can replace this with 6n. So we get 6n by n into n plus 1 by 2 is greater than equal to n into n plus 1 by 2 divided by, the problem has also given us the sum of I by AI. That was given as 2 plus 1 by n. So here we have a 2 plus 1 by n, right? So if we simplify this side, it will become n square n plus 1 by 2, and here there is an n plus 2. No, here there is a 2n plus 1 in the denominator. 2n plus 1. And this side n gets cancelled, you get 12 by n plus 1 is greater than equal to half n square n plus 1 by 2n plus 1. Right? That is what we are getting. Now we can say that 12 by n plus 1 is less than 12 by n, right? So we can write it as 12 by n is greater than 12 by n plus 1, and that is greater than equal to this, right? So I will just write it on the next screen. I have 12 by n is greater than 12 by n plus 1. That is greater than equal to, we have half n square n plus 1 by 2n plus 1, right? And this quantity is, if you think about it, half n square n plus 1 by 2n plus 1 is greater than half n square n plus 1 by 2n plus 2, right? That is equal to, here you can take the 2 common and cancel the n plus 1. So that is equal to n square by 4. So this is greater than n square by 4, right? So we are saying this was our AMHM. This was coming from AMHM, right? And now we are saying this is greater than this and this is greater than this. So we get 12 by n is greater than n square by 4, which means n cube is less than 48, right? Which implies n is less than equal to 3, right? Now we can say when n is equal to 1, we have a1 is equal to 6, 1 by a1 is equal to 3, and that is a contradiction. Using the statements of the problem, we can establish a contradiction when n is 1. When n is equal to 2, we have a1 plus 2a2 is equal to 12. We have 1 by a1 plus 2 by a2 is equal to 2 plus half. And for this, we'll have no integer solutions for n. No integer solution for n. N has to be an integer. Here we'll not get an integer solution. Not n for a1 and a2. a1 and a2 are not coming as integers, which was given in the problem that a1 a2 were positive integers. So n is equal to 2 also doesn't work. Our last chance is n is equal to 3. So for n is equal to 3, you will get a1 is equal to 6, A2 is equal to 3 and A3 is equal to 2. After solving the equations, I'm telling you the solution. And therefore, all of these three are integers. So n is equal to 3 is the unique value of n which satisfies the conditions of the problem. So basically, AMHM helped us establish the condition on n, which was n cube less than 48. Right? And only when we get n cube less than 48 are we able to say that we can find the value for n here. Right? So that concludes our discussion of the mean value inequalities. In the next video, we'll look at the Cauchy inequality. So stay tuned for that one, and I'll see you next time.